Hello everyone, we are gonna review in this session how to create a modular Revit add-in able to suit different teams and projects. The main contents we are gonna review is, first of all, why automation is important, because this is what we are talking about. Creating tools is automation. What are the options that the companies have, and Atlas personal automation journey and the strategy we follow to create our tools. My name is David Llorente. I work in Atlas Industry, a project partner delivery supporting other companies to develop architectural and engineering projects. In my position as digital director, I am in charge of overseeing the BIM management projects, the visualization requests, and the research and development initiatives, including automation tools, data analysis, artificial intelligence. First of all, we are going to review why automation is important. It's very important because our industry is facing very important challenges. On one side, we are facing an increase of demand. By 2060, the global building floor area is expected to double. Additionally, the built environment is responsible for most part of the global carbon emissions, and clients and governments are getting more and more concerned. And additionally, our specific industry is facing some challenges like a skills gap, labor shortage, increasing complexity, increasing amount of data, and low margins. So in order to face these challenges, we have two possibilities. On one side, we can increase our workforce by 10, or most probable, we will increase production speed by 10. That's why automation is not only important, but is going to be necessary in the coming years. So what are the options that the companies have? Basically, we can say that they have two main options. The first one is to purchase proprietary add-ins available in the market, and the second one is create a research and development team and create their own tools. So both of them have positive and negative points. So when we purchase Revit add-ins available in the market, the positive points for this is that we have a big variety, and normally the cost is reduced. So if your team is small, it's probably the best option for you. There are free versions of the tools additionally, and they are flexible and they provide a professional technical support. On the downside, it's necessary to research which tools your company needs, and you will need to purchase probably several add-ins. You cannot customize it. The add-ins evolve in the way that the company creating the add-ins want, not your company want, and sometimes that can create problems. Additionally, they don't allow you to report how you use the tools. When you create your own tools, this is a good solution. I mean, the advantages are that it's something flexible and scalable, and you can customize and adapt for any kind of project or any kind of team or any kind of problem that you want to solve. You can create your own data analysis and KPIs, and having a technological expert, because the person developing this tool will become an expert, is good because it can raise interest from other team members and be a reference for them, and it will change the perception of other companies have to your own company, and potentially will develop new services for your company. But on the downside, doing this requires to create an extra team that needs to be managed and needs to select priorities and needs to have goals, deadlines, and KPIs. These profiles are sometimes not easy to find, and they are potentially expensive in this moment in the market. Additionally, this option has a steep learning curve, and you require constant training and research, and developing the first set of tools can take some time. So it's necessary to be patient. So these are the two main options, and you could think that they are contradictory, but in reality, the best solution probably is to have a mixed approach, to buy the tools that they are already in the market and are good for your company and adapt to your problems, and in addition, create your own Revit tools to customize and to solve specific project problems. So this is what we did in Atlas, in our company. Our automation journey was like many other companies. So it started organically. Some people in the company that they were very talented and had a natural interest in programming, they started developing tools and scripts in Dynamo, and additionally in C#. They started working as a part-time in research and development, and they were solving initially generic problems, but also some specific requests from the users. With the time, the number of tools was growing, and they decided to create an initial Revit add-in in C#, and it was installed for some users. As the tool was getting popular, it was clear that it was something good, and the management decided to do a global installation of the tool and a mandatory training for everyone in the company. At that time, we were also promoting weekly automating meetings in order to make this tool and the automation processes more and more popular. We were as well collecting some basic data that you can see here below to generate some analysis. This here in the right up corner, you can see how this initial tool looked like. This was the tab in Revit. So we had something that it was working, but it was clear that it had some limitations. For example, the maintenance was very difficult. Every time we wanted to do an update, we needed to reinstall in every computer. That made the testing very slow, and that made the scalability as well very slow. It was clear that in the future we would not be able to use this tool if we wanted to evolve fast. The customizations were possible, but limited, because C# is a complex language, and the collaboration between departments was as well difficult. Additionally, we still had some Python and Dynamo files that couldn't be integrated. So we had the main tool and some scripts that they were stored individually. So we decided that we needed a new strategy based on the following principles. We wanted something centralized that was easy to integrate with Revit and fast to maintain and update. A tool or a series of tools that were modular, versatile, and customizable, with a central reporting system, so all the data was structured in the same way. So the main pillars of our automation strategy were the following. First of all, the one we are going to dedicate more time, was the creation of a central tools library. But we also created a developers group for the whole company and a standard tool development process. So for the creation of a central tools library, that was the main goal. And the idea behind this was to all these tools that we were creating independently, we finally end up in a central location. So the users, they don't need to explore or ask or request updates. All the tools are in the same place, and there is only one place to go to discover what's new and all the automation possibilities of the company. We needed first to select our preferred platform. We had three main options at that time. We had on one side Dynamo, Python and Revit, or C#. Dynamo is a very good tool to start learning how to do coding and automation. It's visual programming. The problem is that the functionality is limited, so you finally need to learn Python to do other things. And if the task or the amount of data is very complex, or the amount of data very big, the script could crash. So sometimes you create scripts that you cannot use. Python and Revit is a flexible solution. It's easy to learn and it's ideal for beginners and to grow fast. And in addition, Python is the artificial intelligence language. That means it will become more and more popular in the future. The issue is that it's not natively integrated with Revit, and the performance for big amount of data is a little bit inferior to C#. And C# is the best option for complex projects and ideal for standalone applications, especially if you look for commercializing the tools that you create. The problem is that it's much more complex and it's more difficult to learn. So for us at that moment, we decided to use Python and PyRevit. So PyRevit is a free Revit add-in. Okay, you can download it and install it. And it provides already a default tab with some useful tools. But additionally, the good point of PyRevit is that it allows the users to create their own tabs, scripting in Python. You can also run Dynamo and C# scripts. And it's important to highlight that it's an open source project, which is good because it has a big community and a huge library of free resources available for the developers. PyRevit is easy to integrate with Revit. In the case of C#, your developers need to develop the scripts and additionally the Revit add-in to connect with Revit. PyRevit, however, offers a simplified environment. PyRevit will make the connection with Revit, and your developers, they only need to focus in the Python scripts, which is much easier and flexible. This is reflected in the structure of the files. In C#, the structure is flexible and more complex, and in PyRevit, we will see it in more detail right now, the structure is predefined, meaning that depending on the name of the folders, it relates with the structure of the add-in that you want to create, and it's easier to follow. The tool updates are easier in PyRevit as well. When we were using C#, once you have all your scripts or your add-in, you need to create a DLL file, and this DLL file needs to be installed in every local machine. That's why we were having problems when we were doing updates. In the case of PyRevit, the scripts can be stored in the local computer, yes, but they can be stored as well in the central server. So all the computers connect to the server. Once something is modified, all the computers at the same time will receive the update. That's why it was one of our decisions to locate the tools in the central server. PyRevit is modular, and this is very important. As I mentioned before, depending on the structure of the folders, you will get different elements in your add-in. For example, in the red lines, you can read the folders called panel are the different parts of your add-in. We will see Atlas example right now. So in this case, you can see three, the panel 1 in red, the panel 2 in blue, and the panel 3 in yellow. And inside, you can put buttons or menus with drop-down, pull-down menus with more buttons inside. So in the panel 1, for example, you can read tool group 1 pull-down. That creates a menu, and inside you will have more folders with a push button denomination, meaning that this is already a tool, a script. So you allow your team to create and evolve and improve the areas or the blocks of tools that you need the most, and the rest of them, they can be developed later on, but nothing stops the evolution of the tool. This is the example called PyAtlas that we developed in Atlas. This is the main tab. As you can see, it has different sections. For example, the R&D core panel, the annotation panel, the datum, audit asset, etc. And inside, different buttons. We are going to see now more in detail the annotation tab. So the annotation tab is it contains several buttons, and for example, if we go in detail to the task, the anno task, you will see the different tools inside. So the anno task is a pull down folder, and inside you have several buttons and several scripts. So again, it doesn't matter what is the structure, it's very simple to create by following PyRevit structure of folders. The tool was growing and evolving. Now we have more than 120 tools, and as PyRevit is very flexible, we created other tabs to simplify its use. So we had PyAtlas tab, which is the one that we just saw, which is with generic tools and is public. We have the PySupport tab, where we put inside specific tools to solve project problems. So we have the generic tools, we have the tools customized for specific projects. We have PyCAD, where we started creating tools for AutoCAD projects for automation. And we have two private tabs. On one hand, the management tab and the tested tab for new tools. This is just an example for you to see how our tools look like. This tool, for example, is able to list down all the warnings of a Revit file. So normally, the selection and filtering of warnings is not handy in Revit. When you click out, you lose the warnings. Finding the element is complicated. So we created a tool where you can filter these warnings. You're going to see it right now. You can select the warnings you want to look for. And you will get a list in a panel. There you have it, where you can find and isolate the different elements, making very easy to fix and saving hours and hours of abortive and intense work. We are also collecting a big amount of data, so we are able to create data. I mean, we are able to create our own analysis of the tools, and we are able to know what are the tools that they are used the most, what are the projects that are applying more efficiency, etc., etc. And with that, we create monthly reports for the company to be aware of it. This reporting system is evolving, and we are working now in an online system with Power BI that it can be updated in real time, and it will be available with the latest information for all the managers and directors of the company, so we can know anytime how the tools are performing. We found challenges when developing this tool. The most important challenges that we found were two. The first one was security and IP. It's necessary to say here that the perfect system does not exist, and Revit is open source. That is good because you have a lot of free information, but it's negative because in the security field, because it's done to share information. But still, if you want to protect your scripts, there are options to apply. So what we did in Atlas, we applied several actions that we were combining to protect the scripts and the code that we were creating. On one side, we did server authentication, allowing only the users to use our add-in only if they connect through Atlas server. The IT team created a restricted folder in the server where machines could access but not users. And additionally, we were compiling the scripts. Instead of DLL, as C# would have done, we were creating PIC files, which is a kind of scription. The three solutions combined were providing us this security for our scripts. Additionally, it's possible to, when the tool is growing very big, it's possible to have some performance issues because Revit needs to translate the tools from Python to Revit to C# to allow Revit to read them. The bigger is the tool, the more time it consumes. Additionally, we were storing the code in the server of the company, so that already was creating some latency. I mean, the computers need to connect to a central location in the server, and that was taking more time. Additionally, the projects that we are dealing with are very big. It could make the tools slower than expected. The solutions that you have for that are two mainly. On one side, you can combine the tools and improve the code, make it more efficient, or you can clean the Revit cache from time to time. In addition, we had two more points of our global automation strategy. The first was the creation of a developers group. The idea was to create a core group led by the research and development team, belonging to the digital team, to ensure that the tools that we were creating are coordinated and stored in the same place. And the communication is made and information is shared with all the disciplines, digital architecture and engineering, and also inside the teams inside these disciplines. Like this, we ensure that all the tools are safe, are located in the same place, are standardized, and they are communicated to everyone. Finally, we also created a tool development process where the developers can create the tool and install it and use it in order not to become a bottleneck, but at the end of the process, the R&D team is taking this tool and standardize and put it in the central library of tools so everyone can access to it. So if you are looking to start creating a tool like us, these are my recommendations. First, you need to select an automation champion and start researching and testing. You need to, at the beginning especially, select reliable sources of information. I suggest to follow Eric Fried's course. He's providing a very good information, and also find courses about Python and Revit API. You need to select your platforms. I suggest PyCharm to develop the code, and to store the code, you can use your local server or a Git system like GitHub. I suggest you to start small and define a short-term strategy, and create and test processes trying to solve generic problems or small problems defined by the teams. Then you can define a mid and long-term strategy and goals. And the most important point is not to give up, because it can be a long-term strategy. So it's important to be constant. And with this, we finish the presentation. Thank you very much all for your attention.